Welcome to 204B, objective number 6. Now we're going to look at how the contacts are configured in order to make sure that our system works a little bit better and in order to reduce any potential problems that could occur. My contact configurations inside my relays goes beyond just what kind of material I use in order to build my contacts. It also depends on how I orientate them in order to reduce any potential arcing that could happen inside. As contacts open and close under load, an electrical arc is created between them, and that arc creates additional heat and in time can damage the contact surfaces. With relay contacts, pitting, oxidization, and heat are problems that are associated with the natural arcing that occurs inside when the loads are being disconnected, and the configuration of the contacts can help minimize these problems and extend the life of our equipment. There's a number of different ways that we can reduce the arcing, and we're going to discuss those as we discuss different types of contact configurations. The first method we're going to look at in order to reduce arcing is by using what's called a bifurcated contact. A bifurcated contact is basically allowing multiple paths for the current to go. If we remember our parallel theory, we should know that if we have the exact same amount of total current flow and the more branches we add to it, that current will be shared among each branch. The same thing applies here. By applying bifurcated contacts, I actually reduce the amount of current on any single contact by half. This is going to reduce that potential energy there and will also reduce any arcing at that site. Regardless of the orientation, bifurcated contacts gives us multiple points of connection, which allows us to share that ampacity load over more suitable areas. A very type of contact configuration that we use in our relays and our contactors is called the bridge type contacts, and this gives us a lot of different advantages. First, it provides very good contact alignment for the opening and closing, so I don't have any missing gaps between my two sets of contact points. And the multiple contacts also split the arc voltage to minimize the arcing, similar to what my bifurcated contacts do. It also provides me with a wiping action, so as these contacts separate, the surface area at which they will finally detach from each other is so minimal that it will also reduce the arcing on them. And it also provides a self-cleaning feature to these contacts. There is another aspect of contactor design that will also help reduce any potential arcing. We find that arcing is increased when the contacts are opening and closing slowly. The slower the movement is between the contacts, the more arcing is going to occur. So we have two different ways to prevent that. When we have a normally open contact that we wish to close, we're going to size the coil in such a way that it's going to activate that armature very quickly. It's going to pull that armature in, close the contacts, and we want that to happen very fast. On the other side of that, when I de-energize that coil, those contacts have to open again. And once again, we want that to be a fast-acting action, so we're going to provide an armature spring. This armature spring has to be sized very carefully so it does not push too hard against the coil's magnetic field. However, it's still going to push hard enough to open those contacts as quickly as it can. In addition to my armature spring, I also have contact springs. The contact spring's job is to keep the contacts tightly closed together while absorbing the impact of the relay closing. The contact springs are always located on the moving contact, and they have to be strong enough to withstand any rebound action that might happen from the action of those two contacts coming together. Both the contact springs and the armature springs have to be carefully balanced to the forces applied to them, otherwise they could cause more issues such as chattering. You've reached the end of 204B Part 6. This objective has focused on how to reduce the arcing inside a contactor by changing the contact configurations. Be aware of the 4 different ways that we can reduce arcing by addressing the opening and closing time with my armature spring, by reducing the contact bounce while maintaining good contact with my contact spring, by providing a wiping action with my bridge type contacts, and also by providing more paths for current by either adding bifurcated or bridge type contacts. Make sure you are aware of all 4 of those methods and you understand how they apply. When you are comfortable with this material, continue on to 204B Part 7.